Hi everyone, I'm Pat Prokop out here in the heavenly backyard garden. Now, if I asked you a question, what is the most beautiful planet in our solar system? Well, I guess a lot of you are going to say, well, that's an easy question. It's the planet Saturn, even though Jupiter does get quite a large number of votes. But anyway, Saturn is now approaching what we call opposition, where the Earth is directly between the Sun and the planet Saturn. And it's also the best viewing time to capture the ring planet. So that's what we're going to do today. We're going to capture the planet Saturn on video, and also let's find Pluto while we're at it. Welcome to Heavenly Backyard Astronomy. When it comes to photographing the planets, several things are needed that are beneficial to get the best pictures of the planet. Number one is the telescope itself. You want a telescope with a long focal length. The longer, the better to an extent. But what I'll be using is the Celestron 11-inch Edge HD at f10. At f10, that gives me a focal length of 2,800 millimeters. That's a very long focal length. But you need that for the planets because actuality, the planets appear very, very small in the field of view. And with the shorter focal length, the planets appear even smaller in the field of view. So, number one, a large focal length or a long focal length telescope. Number two, a planetary camera is beneficial. Not needed, but beneficial. And by planetary camera, I'm talking about something with a small pixel size. The smaller the pixel size of the camera, the larger the object's going to appear in the field of view. So the planetary camera that I'm using is the ZWO ASI 585. It has a pixel size of 2.9 microns. So a small pixel size camera is beneficial for capturing the planets. What else you need? Well, the software to capture the planet. And or the planets if you're going to go out planet shopping, which will be happening soon in a sky near you. There's two really good programs out there. SharpCap Pro is what I use. FireCapture is another one that's very useful for capturing the planets. But my experience that I have, I use SharpCap Pro, and I like it a lot, and it really does good in capturing the planet. And the next thing you want to do is use a region of interest, ROI. And with that, you can shrink the size of the view down to a very small area that you're capturing. You don't want to capture the whole sky because most of that's going to be black or some stars in the background. What you want to do is just capture the smaller area, and with that you should get more frames per second. So that's another thing you want, high frames per second. The higher the better. And I try to shoot for around anywhere between 50 to 100 frames per second with a region of interest set. And usually for the planets, it is way down there to 320 by 240. So it's a very, very small region of capture, region of interest for the capture. All right, those are the things that we really need to capture the planet. And then after capturing the planet, you need a software to analyze it. And two of the software values or programs that I use, one is AutoStackered, and then with AutoStackered, I use Registack 6. And the combination of those two put the planet in perspective and give you a great view of all the different frames that you captured. When you're capturing the planet, say in SharpCap Pro, you want to make a movie file, either a AVI file or a SRC file. Anyway, I usually try to get at least 1,000 frames per movie file, sometimes 5,000 frames, even up to 20,000 or 25,000 frames in a movie. And that'll take a couple of minutes to capture. A 25,000 frame movie at about 50 frames per second is going to take about 5 minutes to capture the planet, a little less than 5 minutes. Anyway, that's what you need. All right, well, speaking of that, let's go inside where it's cooler. Right now, I'm out in the heavenly backyard garden. It's 90 degrees, but the humidity's up there right at this moment, and that gives me a heat index of about 100. in Celsius, what is that, 38 degrees? It's hot out here. But I guess that's why they call it August in Savannah. Anyway, let's go inside where it's air conditioned.
All right, let's take a look at SharpCap Pro, and here I have the planet Saturn lined up and amplified somewhat. There's 300% amplification right there. Let's look at for the moons first of all, and two things. It's difficult to focus during the looking through the atmosphere, and the lower the planet is on the horizon, the more difficult it is to focus. But fortunately, I had a somewhat decent atmosphere this night. Now, if I overexpose it, the moons will begin to show up. And I found it's a little bit easier to focus using one of the moons as the focal target. And I'm going to try to find Titan right now, and it's off to the right. There's Titan right there. That's that big moon. Titan is bigger than the planet Mercury. It's a huge moon. It's the second largest moon in our solar system. The only moon larger than Titan is Ganymede, the large moon orbiting Jupiter. And Titan does have an atmosphere, but it's mostly methane and nitrogen. All right, let's try to focus in on this. Let's move it over just a little bit here in the region of interest. These smaller moons, I can focus on them as well, but it's easier to focus on something like Titan right there. And there you can see the atmosphere just blowing the light all over the place. Of course, the sharper you get it into focus, the less diffraction of the light that you're going to be getting. And that's a good way to focus on these objects that are in the solar system itself, looking through the atmosphere. That looks pretty good. All right. All right, let's zoom it back out a little bit. You can't get the moons without overexposing the planet. How many moons does Saturn have? I think it's something like 158. It's an insane amount of moons so far, as of today. All right, let's capture this. I really don't need a whole lot of images on this one here, so I'm just going to do 100. That's all I need. Done. All right, let's now get the planet itself. The planet that will be used for the moons. I'll superimpose this over the moons. I'll do that in Photoshop. Also, I had a very slow moving jet stream, or virtually no jet stream at all. So if you have a jet stream flowing overhead, even though if your sky is clear, you're going to get a lot of turbulence in your atmosphere. So that helps as well. I had no jet stream that evening. Now let's change the region of interest. This is 640 by 480. That might still be a little bit too big. I think I can go a little bit lower. Let's try the 320 by 240. I think that'll fit. Yeah, there it is. So the smaller you have this region of interest, that's just zoomed in, the more frame rates you're going to get. Also, the speed of your shutter or your exposure speed will also maintain your frames per second. Right now I have it set at 50 milliseconds. And that's a pretty clean picture there. I mean, that's not bad for a live view right there. So I'm going to make the movie file with this setting right here, and we'll just let it go at that. And I'll process that in Registack and in AutoStacker first, then Registack. All right, let's take a look at AutoStacker right now. Here's the shortcut to it, and I'm going to click on that and open it up, and you get these two screens right here. And what I'm going to do is open the file, and let's pick a file. Let's do this file over here on the 28th, let's say, and Saturn 4, and let's pick on this one right here. And that had 5,000 frames. It's an AVI file. The first thing I do is I go in and move this slider up here to find a good frame. And that one, it looks pretty good right there. All right. And then I'm going to place the grid on here. And I have it set at 48 value here. And I have all these things checked off and just place the grid. And there it is. These are all the data points that it's going to use to calculate for the stacking and for centering the planet. All right, the next thing I want to do is over here, make sure it's clicked on the planet. Now, if you're doing the moons, if you have a wide field view of the moons, you might want to click on the surface. But the planet is good. And I'm going to keep that as a dynamic background. I'll keep this at local for the moment. And I could do double stack reference. I'm going to show you an example of that coming up, but right now I'm just going to keep it off and hit analyze. And it's going to analyze all the images, 5,000 images in this file. This is a relatively medium-sized file. I have smaller files and have bigger files, 20,000, even 50,000 frames. All right, there's the quality graph right there. It looks like most of them are pretty good. So over here, you can use your whatever you want. I can take like 10% of the best frames, or I could take 25%, whatever number you want. And I could take 50% of best, 50, not 59, 50. All right. Or you can actually pick the number of frames you want to save. Now, I always save them as a TIFF file, but you can save them as a PNG file or a FIT file. And you can play around with these. I just keep them off right now because RegiStack is going to take care of all this over here. So I just leave it alone. And then I hit stack. Now, you can drizzle it if you want, but I'm not going to drizzle it. I'm just going to just take the images and stack them right there. And that's it right there. Almost done. And done. All right. Now, the next thing I'm going to do is I'll close this out. And I'm going to go to RegiStack 6, RegiStack 6. I'm going to select the file over here that I just imaged. Let's bring that up. It's on that one right over here. Here. And let's do the 10%. Let's take the middle one. Take 25%. Okay. There's the image that it's stacked. All right. There it is right there. And what I like to do is click on this option here, show full frame. There's the planet as it's stacked. Now, so this is dyadic, and you can change the settings. Like, for example, the wavelets, they're 1. You can see how that changes if you move these things around. It changes a little bit. I had a glare right there near the equator, but that looks pretty good right there. And what you do once you're done, again, playing with all these settings to where you like it. And if you do like it, I highly recommend you save the scheme, and then so you can call it back later like I just did right here. And then you do all, and then you save the image. And there it is. I'll save it as Saturn P25. That's 25% of all those files, images from the AVI file. And there you go. So if you want to play with these values over here, the RGB balance is a good one to play with. It's automatic, just say auto balance, and there you can see it. It just does the color balancing. I can also do this in Photoshop. If you don't have Photoshop, this does a pretty good job. But I like to sharpen it up a little bit more in Photoshop. But that's how I do it over here in the using AutoStackered and RegiStack 6. Both of these programs are free. Wouldn't hurt to donate to them, but they're free. And just I have links to those in the comment sections, in the description area below. So links to these if you don't already have them. All right. I mean, this is not the only way you can stack, but this is the way I like to do it. All right. All right, let's take a look at the different standard stacking versus double stacking of the images of 10% of best frames of 20,000 frames, 50% and 75% of the stacking inside of AutoStacker. Now, if you look at the conditions for the standard stacking at 10% versus 50%, I don't see too much of a difference. The 50% looks a little bit cleaner. All right, let's move along and take a look at the difference in the 50% standard stacking versus double stacking. And once again, it looks like the double stack is a little bit better, not by much, but I would go with the double stack on that one, maybe a little bit better. And if we look at the conditions for 75% of the double stack versus the standard stacking, once again, in this case, boy, it's hard to tell. The double stack is a little bit smoother, but I see a little bit more banding in the atmosphere on the standard stacking at 75% of the 20,000 frames. Now, if we look at the standard stacking at 10% versus the 75%, there you can see I can see more banding on the standard stacking at 10% versus 75%, but 75% is a little bit more smooth, so you take one with the other. And then one more, we have another one, there it is. The difference between double stack at 10% and double stack at 75%, which one is better? It's hard to say. I can see more banding in the atmosphere at 10%, but I see smoother atmosphere at 75%. So, yeah, the difference stacking, not much of a difference. If you're in a hurry, 10% of the frames, you get the best 10%, but for smoother stacking, you need more frames. So you might want to consider setting your system up to do either 10%, 50%, or whatever value. Take a couple different values or 3 different values and then take the best one out of that. All right, let's take a look at this view here. This is a view with the planet Pluto in it. Can you find Pluto anywhere in that image? Well, how about if I show you the night before? Now, if Pluto is in this image, the stars will remain fixed and the planet will have moved. So let's go to the night before, and that's this image right here. And I click on it right there. Did you see it move? See it? Right there in the center. All right. And the night before that was this view. It's kind of cut off, but there it was way over there. And then it moves there. Then it moves there. There you go. There's the planet Pluto. What do we know about Pluto? Well, not that much as far as brightness is concerned. +5 is about the farthest thing your eye can see. Usually it's +4 or +3 in the urban areas of the suburban areas, rather. In the cities, you probably can only see a magnitude 2, 1, or 0. Anyway, this is a magnitude 14.39. Not very bright at all. Not the brightest bulb in the sky, but there it is. There's Pluto as it moved across the sky. There you can see it going backwards in time and going backwards in time. This was Tuesday night, Wednesday night, and Thursday night. There we go. The planet Pluto. Yeah, you can see Pluto. Wow.
When I started my venture in astrophotography back in around 2017, I never imagined trying to capture the planet Pluto. But here it is. You can do it now, even though I'm not going to get much details. I mean, gee whiz, the planet is what? 3.1 billion miles away. Saturn is relatively close when you're talking about Pluto. Saturn's only, what, 800 million miles away? 807 million miles away. Yeah, well, it's still far out there, but anyway, it's a much bigger planet too, and it has more gaseous displays, giving off more of the light that you see. And the rings, well, the rings, they're getting more sideways now, edge on at this time, and by next year, it'll be just a little, like a line shooting across the planet. But if you look at the planet over the last several years, there you can see them right there. You can see how the rings have changed their tilt over the years, and that's I think it's a 27-year cycle that it goes through. Anyway, I want to thank all my viewers who have supported my channel, And there's the list of the names over here, wherever they are. There's the list of the names of the members of my channel and those who have supported me through Patreon, through becoming a channel member, buy me a coffee. It's very hot out here. I still drink coffee inside where it's air conditioned. You can buy me a cup of coffee, $2. Here's another thing. YouTube is again changing their algorithms, and what I hear, they're taking away the posting of the views of each video, and they're only going to be posting the number of likes of the video. So with that being said, please, if you can, hit the like button. Of course, if you don't like this video, don't hit the like button. But if you like the video, please hit the like button, because that's how YouTube is going to start counting these videos and pushing them out to other people to see the videos. So that would help me a lot. Again, thanks you very much. And you know, the other planets are coming into view right now as well. You got Neptune and Uranus out there behind Saturn coming up in the eastern sky. And then following that is mighty Jupiter. And Jupiter will be rising about 1 o'clock in the morning now. And then following Jupiter by about an hour is the planet Mars. And Mars is going to be fiery red this year. It's a dull ruddy red right now, but it's going to get a bright ruddy red coming up in October and November. So be on the lookout for that. And the other planets, Venus and Mercury, well, Venus is getting ready to make its appearance in the western evening sky for the rest of the year and going through Christmas into the new year. And Mercury, well, it's just all over the place. Right now it's in the morning sky. Very hard to get Mercury because it's always low on the horizon. Anyway, those are the planets, and also there's more up in the sky besides the planets. There are the galaxies, of course, and there are the other nebulosity objects. And I'm going to be showing you more about that. I have a new mount that I just acquired, the AM3, the ZWO AM3, and I'm testing it out right now. And so far, I am just blown away by its tracking ability. So that's coming up. Anyway, thanks for watching, and remember, the heavens are filled with majestic wonders, and they're all in a sky near you and even in your own backyard. So with that being said, clear skies, everyone.